Welcome, Brian, to Google Developer Group Soweto with composing UI in Kotlin. So tell us about yourself and what do you do?
So hi guys, I think this is part of the introduction in the slides, but it's okay. I am Brian Odhiambo, but so many people call me Mambo. I am a mobile engineer at a fintech company in Nairobi, Kenya, and we deal with basically um, creating software for banks, microfinances, and circles.
All right, awesome. Just tell us a bit about what you're going to present today and also composing of UI with Kotlin as well. And then you can get on with the presentation for everyone.
Okay, awesome. So today we are going to talk mostly about how to really use how to really use Kotlin to understand Compose, because uh, Kotlin is a prerequisite to understanding Compose, and today's talk is just going to like just briefly talk about how to approach Compose by understanding Kotlin.
All right, thank you. Welcome everyone for joining us to the GDT Soweto. This is Mambo Bryan composing UI with Kotlin. You can go ahead, Brian.
Okay, awesome. Let me just try and share my screen. Uh, can anyone see my screen?
Yes, you can see your screen.
Awesome. Thank you so much for having me. So today we're going to talk about being a Compose champion by understanding Kotlin. And this is very important because the Android ecosystem is clearly moving to Compose. And the Compose UI framework is really rapidly growing. So this talk is just to help anyone who'd like to get started or just to dive in deeper with Compose and how to do it. So as I mentioned earlier, I am Brian Odhiambo. You can call me Mambo. I am a co-organizer for Kotlin. I'm maintaining something called Kotlin Bits, that is just to share Kotlin in small bits for those who are starting out or those who are continuing and would like to increase their knowledge in Kotlin. Also, I'm a mobile engineer at a fintech company here in Nairobi, Kenya called NLS Tech Solutions. And basically what we do is create software for finance companies such as banks and microfinances and circles. So I'm very heavily involved in security. And lastly, I can say I'm a design-centric engineer. It's not a good thing to to others, but design meaning like I would think of how it looks before trying to implement anything else. But that's just how I go about thinking about any system. So what to discuss today. Today's session is going to discuss three key areas. What is Kotlin and Compose for those who don't know? Why is it that you need to understand Kotlin so that you can compose? And finally, how do you use now your Kotlin knowledge to really benefit fully in when doing compose? So the what is Kotlin and Compose. So what is Kotlin and Compose? So we can start briefly with Kotlin, since I think it has been the main language that Android has been using since 2017. In short, it's just a pragmatic programming language which is safe, clear, and concise. It's just a replacement for Java, where everywhere where Java is being used. And to see why it is being uh, named as the replacement and why it is being uh, defined as safe and concise. We know there is no null safety. Sometimes you have to catch null pointer exceptions while you're running. And also Java is too verbose. it has a lot of things that you write that necessarily you don't need. And Kotlin handles this swiftly and perfectly by being concise and being safe. The other thing in how is Compose and how it relates to Kotlin. So Compose is just a fast, reactive, and intuitive UI framework for Kotlin. So it is built based on the Kotlin language, and this is how these two interoperates with each other. So now let's look at the why. The why is the parts. Why do we need to understand Kotlin as developers, like someone who's coming to do Compose? Why would you need to understand Kotlin? If you have any questions, you can just put it in the chat. We'd really appreciate. Okay, cool. So one tip I would like to say before we continue, and this is the most important thing. If you do not get anything from this whole session, please, this is it. This is that sentence. If you're struggling using a programming language, then you should understand you're not using it right. Because in essence, what a programming language is supposed to do, it is supposed to help you build faster. So if you are struggling using a programming language, then most probably you are not using it right. Okay? But I would like to give a small illustration. There's this phrase people normally use called sharpen the axe. And it is very important because think of someone who's going to chop down a tree, or maybe even you're going to cut meat, and maybe you're using a blunt axe or a blunt knife. What is the first thing you need to do in order for you to have a smooth and enjoyable experience as you're cutting or you're chopping down the tree, or you are cutting your meat? The first thing you do is you sharpen that knife or you sharpen that axe. Make sure it is as sharp as possible so that when you exert force, the force is not going for a blunt knife. So you sharpen the knife first, then you chop down the tree, and that's it. Simple enough, right? But some would ask, how does this relate to Kotlin and Compose and today's topic? It is the same thing, but now Kotlin is our knife. You need to understand Kotlin, understand it well, and then you can fully use Compose and its features when you understand Kotlin. If you jump straight from, let's say you're in Java and you jump straight to Kotlin, to Compose, it might be hard or difficult for you. Or even if you're in any other language, maybe let's say JavaScript or Go, jumping to Compose directly might be a bit challenging. Why? Because it is built on top of, it's a framework built on top of the Kotlin language. And that's why you need to understand the Kotlin language so that you move swiftly to Compose. Okay, cool. Now we have understood the what and the why. The most important part is the how. How can we use our Kotlin knowledge in Compose? Okay. Now, let's start with a simple and the most simplest thing in Kotlin. This is being Kotlin is also a functional language. It's a Kotlin function. So a Kotlin function is simply like the one on top. It's, you can just write hello world, and inside that Kotlin function, you can print a line. So the fun keyword declares the function, and the hello world is a function name, and inside you can declare whatever you want. That's a simple Kotlin function. And some things that people do not know is that this hello world function, it looks like it does not return anything, but actually it returns a type of unit. Okay, so how is this used in the Compose framework? So a composable, in essence, is just a normal Kotlin function, a bare bones normal Kotlin function. But all you have to do is annotate it with @composable. Okay, when you annotate it with @composable, it tells the compiler that, oh, this is a composable function that should actually render the UI inside it. Also, text here, in the same context, text is also a composable function that takes in a string. And the string right now is hello world. Japa Compose is just, you can say it's like a fork sometime. And the good thing is that the Android team has enabled us to add more features to just normal compose. For example, if you put the annotation at preview, you can actually see your preview in Android Studio before you even run it on a device or any other platform that you want. So for the first thing we've learned is a composable is just a normal Kotlin function, but the difference is it is annotated with @composable. And notice the capital letter at the start of the composable function. If you put this annotation, it will also tell you that you need to start your composable function with a capital letter. So that's the first step. Learn Kotlin functions, then you learn a composable functions. They're basically the same thing. The next thing is okay. So suppose we want to greet someone and we want to say hello, like our function says hello, and it takes in a greeting parameter, which is a string, and the name parameter, which is also a string, but parameter has a default argument, which is world. So if you look inside the function, when you print, when you're printing this to the standard output, all you're doing is just saying greeting, name, and it will take the greeting and the name, and it will print it to the standard output. Now here's a good part. When we are calling this function, all you have to do, if we do not want to pass in the name of the place where we are greeting, all you can do, we can just pass the first argument, and the compiler will know this argument is for greeting, and you don't have to pass in the second argument. Why? Because it has a default argument, and when you pass Jumbo as the greeting, now it will print to the standard output Jumbo world, because it takes the first argument and then the second argument is already declared, and so forth. That is in bare bones Kotlin. So excuse me. How is this used in Compose? How are default arguments in Compose? Well, if you have used Compose, you know that composables have so many default arguments, and they only tell you to provide an argument which is completely necessary. Okay? Let's take the example, texts are composable, but is provided in the standard library. Okay, so we have our fun text, and the first thing is a text. It takes a parameter of type string, which is a text, but it doesn't have a default argument. But the next is a modifier, and the modifier default argument. The next is a color. It already has a default argument, and so on and so forth. So every single argument parameter passed in after text has a default argument. So when you're going to call it, like let's say in our hello world composable down below, when you're going to call now the text, all you need to pass is for the parameter which does not have a default argument, and that is string. So when you're creating text, you normally just pass in the string, like let's say Jumbo world, and that's it. That's all you need to do to create a text inside any composable. But you can also pass in other arguments, like for modifier, for color. But the first thing to understand is all the other parameters have default arguments. The only one that you'll be required to pass are for the parameters which do not have default arguments. Good. Now, after default arguments, what is next? Now, there's something called named arguments. So in Kotlin, you can actually specify the parameter name of the argument you're passing. For example, let's tweak our hello, say hello function. Let's say we have a greeting, which is a string. We have a name, which we already gave a default argument of world. But now let's say the country, and it's a string, yeah? And the default argument is Kenya. When you're printing this to the standard output, we're doing the same thing, and now we're adding a new phrase, welcome to now the country. When we are calling now the function, like say hello in the main there, notice we passed in the first argument, which was for greeting, and automatically the compiler will know that this argument is for greeting because greeting does not have any default argument. But we want to only specify the second argument that we have goes straight to the country parameter. We don't want to pass in for world, we just want to pass straight for the country. How do we do this in Kotlin? We just declare the name of the parameter there, like country, and then pass in the value. So country equals South Africa. And when we run this, it will say, Jambo, welcome to South Africa, like the way I've been welcome. Thank you, guys. So that is named arguments. How does Kotlin now how does Compose use this feature of Kotlin to when UI? This is an example like we already saw earlier. Let's go back to text. Text has a string, but remember it has also a modifier, it has also a color, and so forth, and so on and so forth. All we want, when we call in our text, we just want to specify the color. We don't want to say anything else. We want to give it the specific text. After that, we want to specify the color. And that is what we're doing in our Hello World composable. The first argument is just the text of type string, but the next one is a color. Very specific. Color is equals to color.white. That's how we use named arguments. And they don't have to follow, unlike Swift, for those who have used Swift, you have to follow the, the named arguments exactly the way you call them up top. You see, like in the Hello World composable, we could have started with Jambo, that is the text, and then we go to modifier, and then pass in a modifier. After that, color, we pass in a color. But in Kotlin, you don't have to. It does not limit you to actually pass in the arguments the way you had declared them. So you can just go straight to color and specify the color. So far we have learned about functions, functions, default arguments, very important, and lastly, named arguments. But let's now take it even a step further. Something that Java was not able to do at the time that Kotlin did and was very good at it, and that is high order functions. So for example, we want to greet someone. After that, we want to like show a celebration of the greeting. So we pass in the same same parameters, greeting, name, country. Now we know these things. But lastly, we pass in a function. So say hello will now become a high order function because it takes in a function, and our function is called celebrate. So when we now pass in the implementation of the function inside, we'll say greeting, we'll say name, we'll say welcome to the country, and then we run the celebrate function that has been passed. Because maybe we want different greetings to have a different implementation of the celebration. When you come to call our function now, say hello, notice the curly braces at the end. That is passing function. It now becomes a lambda function because it's at the end of the say hello function. We pass in the lambda, and inside, let's say we just I had printed emojis in this thing, but it seems that they had disappeared. I don't know why, but okay. So we pass in some emojis, and maybe the emojis get printed. Now we can say Jambo world, welcome to South Africa, and the last line is now, let's say, the emojis that we had passed. Awesome. Now that is a high order function. Say hello is a high order function because it takes our celebrate function as a parameter. How does now Compose use this declaring UIs? One thing is when you declare a button. When you declare a button, immediately you'll be prompted to provide an on-click listen. Why is that? Because the button composable has an on-click that needs to be implemented. That does not have a default argument, but it needs to be implemented. Now, that's the first parameter. If you have noticed even before, if a parameter does not have a default argument, what do? We pass it as the first parameter, because this becomes easier for you not to declare the rest. And that's what has been done even with the button composable. It has an on-click function, which does not have any, so to say, implementation. Now, when you are going to create, like in our hello world composable down below, when we are going to create now the button, all you have to do is name the exact parameter. Now we are using name parameters, and now provide a function implementation of the on-click. Okay, we provide a function implementation of the on-click. Now the on-click is equals to, when you pass in two curly brackets, it is an anonymous function. And this is the anonymous function that we'd want when someone clicks something to implement. So when we declare a button, the text is celebrate. When someone clicks on that button, this is what is going to run. Ooh, hello, Soweto. It's going to run because it didn't have any implementation. We have given it an implementation. And I think this is one of the features in
I think we just lost Mambo Bryan. We'll just have to wait for a few minutes or seconds until he comes back. If you have any questions, you can just post them on the chat and tell us where you are tuning in from on the chat as well. Looking forward to hearing from you as well. Thank you. Hi, Danish. Oh, here he's back.
I was kicked out for some reason. Internet problems, I think.
All right, welcome back.
So where was I? I was at high order functions. So I was just saying, this is one of the most underrated features, because the way Compose utilizes high order functions is very easy for someone new to understand and to just start. They don't have to really figure out what is going on inside the hood. But sometimes you really need to know what is going on inside the hood. Sometimes you really need to know. And an example is now our next step is function literals with receivers. This is quite difficult to understand. Hope we'll get to understand it all. So let's say we declare a class and call it market, okay? And inside that class, maybe there is a functionality to buy and sell, and there's this specific function called preview market that takes in a high order function. Why? Because let's say when someone wants to preview the market, you want them to provide their own implementation of what exactly they want to see. Okay, so in our main function, we declare instantiate an object of market, and then let's say we buy and sell in functions inside there. We buy and sell, and then we now reach the part where we'd want to actually preview the market. You will notice the preview market is just a high order function, but the difference is this function has a receiver which is of list string. So it's like an extension function, takes in an extension function, and it returns the list that is inside the market, so that no one can access it outside market, but those inside can actually access it. So for example, when we preview the market, we'd like to just filter. Notice the function filter. Now, because we are in the context of this, since it returns, remember, it's like an extension function. Okay, filter is a function of the list class. So we can actually call filter directly, and it will know we are referring to this specific list because it is in that context. Okay, so after filtering, all you need to do is just print that list. Cool. So that is a function that has a receiver. Declaring a function that it's just a higher order function that takes in a function, but the function is like an extension function in simple words. Like here, it's an extension function of list of type of string. Awesome. So how does compose use this in its in its library? So we have, like, for anyone who has used compose has used the column, like the column and rows. Now, column, at the end of a column, there is a composable function called content. Now, content has it's the function literal with receiver, and the receiver is the column scope. When you try to create a column, the scope in which every composable will be inside that column will be inside a column scope. So it takes in the receiver and gives it back to you. Now you can run functions like animated visibility. And if you look at the function animated visibility, if you go to inside the library, you'll notice it is an extension function of column scope. So it is a function that is an extension function of another function. I hope I was clear there. So column is a higher order function since it takes in the content function, but the content function, remember, has a receiver of type column scope. Okay, and this is how when you declare a column, you can actually get items within that scope because it returns that scope to you for you to use as a context of what you're declaring. Awesome. These are just some of the few ways in which understanding Kotlin can really benefit. You can really benefit when you now try and use compose. So by understanding these few bits, when you now try and use compose, you understand what is going on, why you are passing. For some, you're passing modifier, some you're not passing modifier, some you have to pass text, some you don't have. Like for our column here, we're not passing anything. We're just declaring a lambda at the end. Why? Because the end parameter is a function and doesn't have any implementation. Okay, but then Compose has this, Kotlin has this nice way of doing things, which I think I call spooky stuff, because it is so nice that if you don't know it, you might tend to use Kotlin in a Java-ish way, but once you realize it, you do not go back. So for example, let's say the if else. In Java, if else is a statement other than expression. So when you write an if else, it does not give you any result back. I think even in Swift is the same thing. It does not give you a result back. But in Kotlin, if else is an expression, meaning that if you write an if else and you leave a string inside the curly braces, it will take that as the result of what you'd want from the if else. So having this in mind, let's say someone had declared like our hello world function, someone had declared if something is true, then the text will be this, else the text will be that, right? All these are two composables, and sometimes it is not as simple as just declaring it text like this. Maybe you'll need a modifier inside, you'll need colors, you need padding. So it might be a very long composable, but I've just minimized it to this text like this. So how is it that how can we make this sentence here better? And just you move we can just get the value of the text only because the text is the only thing that changes in this composable. So we can just get and then assign that value to the to a text composable, and that's it. Having this is better than having value is equals to if true this else that, is better than having two composables which you will need to adjust and maintain independently. Now there is only one text, and you can maintain this one text. In case anything happens, you can just add a check up top. So that is one. If else being an expression other than a statement like in other normal languages. So something else is destructuring. And destructuring sometimes it can take, it is tricky to destructure some other things because once you know destructuring, you'd like to destructure everything and just make it simpler for you. For example, let's say we have an icon that takes in an icon composable that takes in an icon and let's say a content description, as we'll call it, title. And the icon is also dependent on if some logic is true. Okay, so we'll come and first check. Okay, so if it is true, I would like to make this rounded icon keyboard up, and if it is not true, then my keyboard arrow will be down. Another thing is the description. If it is true, my description, I need it to be this, and if it is not true, my description, I'll make it to be that. And then we can pass it now down here like icon and title. And this can work, and this actually works, and it works very nicely. But suppose you want to add something else. Let's say a color to this check. Maybe you want this icon to have a specific color. You would come again and add another check just below the description, checking if it is true this color, if it is false that color. Okay, and now this will now become a redundant part in your code that every single time it changes, you will need to come and update that whole part. But how can we like shorten this to make it easier for us? So one example is this, using destructuring. So it's just dismantling a pair to two separate variables, right? So we're checking if it is true, creating a pair of just two values. The first is the icon, and the second one is the text. But notice the actual value that is being returned is destructured to an icon and title specifically. Yes, we know it's a pair, and we can come down there and say pair.first or pair.second, but isn't it more cleaner to just destructure it completely, and now someone else coming will know, okay, we were declaring something and we destructured it to an icon and a title, and now we can pass it directly to now the composable function. This can work for pairs, it can work for triples. You can also add quadruples if you want. It depends with your use case. But destructuring is one of those superpowers that in Compose, I have been using it every single time because let's say, like, for example, a like button. A like button, maybe it has a different color, it has a different icon, maybe this one is filled, this one is outlined. So you need to change all these things in the same composable. If else number of times is not really scalable. So one way I found a solution is to just use tuples so that you can destructure them completely. Good. And that's it for the spooky stuff. There is a lot of more spooky stuff. Hope I would get even more time to talk about even greater spooky stuff, like local functions, how they can help you in Compose, just abstracting some redundant repetition code inside your composable just to a local function and then keep calling that function. Now, I've gotten a number of questions from people who'd want to start doing Compose, and one of them is, how much Kotlin should I personally learn before jumping to creating Compose? And I would say just the basics is enough. If you've seen, we've just discussed about some of the basics. if you have your basics well enough, I think Compose will be a smooth ride for you. But what are the basics? The other question is, what are the basics? The basics is just literals, functions, know your collections, know your flows, if else conditionals, loops, and ranges, know your classes very well, and maybe safety, try catch and not null. I think understanding just these few things will give you a very good start in understanding Kotlin and Compose itself. So thank you so much, guys, for listening. Thank you for tuning in. And that was it from me. If you have any questions, you can now shoot.
All right. Thank you, Mambo Bryan, for having us here and also giving us insight into UI for Kotlin. If you have any questions, please post them on the chat so that we can be able to respond to you. Otherwise, while we wait for questions, I have a question myself. How
Yes.
does UI programming contribute towards the functioning of the app?
How does UI programming contribute towards the functionality of the app?
Yeah, as an
Okay.
engineer.
Let me go back here and put this here. At least
All
you know,
right.
I know Kibet is here. So I am very design centric, and
Yes.
I think from from some of the people who have been working with me, they always know, like, uh, I do not skip on design because design is really heavy, and you can have a good idea, but if you do not have very good design, then your app becomes unusable. Okay, so it design and UI is like, how do I put? It's like the bread and butter of your application,
All right.
because the user won't see your business logic at any given point in time. They want
Mm-hmm.
to come and this button, when I click it, does it go to where I need it to go? Does it take time to go to where I need it to go? Or does it just show me very junky animations and stops there? I think UI is very, very important.
Right. Awesome. We have a question from Lucille. How long have you been doing Kotlin?
This is the third year. Yeah, this is the third year. Yeah, this is the third year of doing Kotlin. So I think in August it will be the fourth. We'll be going to fourth.
Oh, that's great, actually. So, we have also a question from Nisiha again. What's your opinion on Flutter?
You have very difficult questions. That's a tricky one. Okay, so I would say this. It depends with your use case. I remember us talking. I think even Kibet was there with my friends, and we were saying Flutter is very good for an MVP, minimal viable product, and that's it. But once you start, your users want performance. Once you start
Mm-hmm.
using like native libraries and that, you'd start finding Flutter a little bit more difficult. But you
All
see,
right.
not necessarily saying Flutter is not the way to go, but I would also say just try and look at your specific use case. Try and understand, what do I want to ship, how do I want to ship, and how fast do I want to ship. Having that in mind, you will know whether to go for Flutter or to go for Kotlin. But you see, right now there's Kotlin multi-platform. So Kotlin multi-platform is also targeting many what is the word? Many platforms, and it is gaining traction faster than I think the team thought it would, because I think Compose right now has reached 1.4.0 stable, if I'm not wrong, and that is just in a few years of just releasing it to the public. So you better watch out. Better watch out, you Flutter guys. Better watch out.
Awesome. Dennis says, how can we achieve multiple sections in Compose like we did with the Recycler view?
Ooh, whoa. Okay. Um, that's a nice question. So this is something I've noticed why with people who have come from the XML way of doing things. Unlike XML or the view system, Jetpack Compose main functionality is not to make you think of how things are going to be. It's giving you all the tools to make for you to make your own UI the way you'd want to be to make it. Let's say, for example, we have a scrolling list that is scrolling horizontally, but some items in that same list scroll vertically. In essence, that means that if I'm going to a long list, between my items, there'll be an item that also has a list inside it, right? And I think in Compose, all you have to do is just check if you want to render a list or not. If you want to render a list, then you can just put in a lazy column inside your parent lazy column composable, or lazy row inside your parent lazy column composable for specific items, and it will render it and just what is it called, like draw it on the screen the way you'd think. This, I think, would be very difficult in XML. You'd have to think a lot, but in Compose it is that simple. It's just a lazy column. When an item you'd want an item to be now a row or a lazy row, just pass it as a lazy row with now the list inside that item, and it will render it for you.
All right, thank you. Just a reminder, if you have any questions, just pop them in the chats. And another question for me is, how can one differentiate between languages widely used for programming in mobile web development, such as C++, Kotlin, as they have like your similarities in terms of functions that are used?
Mm, nice question. Differentiating differentiating sometimes is very difficult. But if I think if you go even to the Kotlin webpage, they always say they take readily used or readily adopted things from other programming languages. Like I think when they started, they didn't think that they'd want Kotlin to be functional, but once they saw how good, easy, and maintainable functional programming is, they just added it to their own language. And this is one thing I personally like about Kotlin. They would sit and listen to developers actually using it and ensure that they're giving developers what they would need other than just like what they would want. So if it is functional, you'd want to do things functionally. They will take the functional approach and add a little bit of functional programming inside it, and then continue and build based on that. As for something like C++, oh my days. Hey, C++ is like a world on its own, honestly. I tried doing C++
Mm-hmm.
at the start of this year. It was not as easy as I thought. It is actually very difficult to do things in C++. That's why people are moving to like more modern programming languages, which are more human readable other than machine readable.
All right, so just a wrap up in terms of your overview of Kotlin. How do you plan to develop further into being a design-centric engineer using Kotlin, or do you also have plans in terms of integrating other languages into your engineering goals, actually?
Oh, nice question. Um, Right now, my stack is Kotlin, Swift, um, Elixir, and Postgres. Since I do love Elixir and how it handles um, when a service goes down, I do love Kotlin for how easy it is to just learn and develop with. And Swift, it's because I just need Swift. If there was any other alternative, I wouldn't be doing Swift. But there's also something about Swift that is very, very different from Kotlin. That is its type system sometimes is a little bit, I would say, a little bit better in some way compared
Mm-hmm.
to the Kotlin one, and I hope uh, with time we actually get there. For my own personal learning journey, I always like tinkering and experimenting with Kotlin and Compose. Like right now, you can actually run Compose on iOS, and this is something that I think I personally would enjoy. Just trying out as the programming languages grow, you try out new things with it.
All right, awesome. Thank you for your time and also sharing your insights on your journey and the language that you use in terms of being a mobile engineer. Just in closing, what do you advise people on having to become a design-centric engineer into the world of tech?
Hmm. Hmm. I think when I started out, UI UX was not that big of a deal, and it was not. I don't think it was that much of a career as much as it is nowadays, because people did not think like UI UX is something that people would consider like is it that important? But
Mm-hmm.
as we go deeper into a technological future, you'll start seeing very similar products. Let's say, for example, Netflix and HBO, or Disney Plus, something like that, or Apple Music and Spotify. They are the same services, though. They're exactly the same services. But what
Mm-hmm.
differentiates the two? Most probably, it starts with UI and user experience. Mostly it's the user experience and then everything
True.
else. So just try and figure out, if you are creating a product, the one using the product, how do you want that person to feel when using your own product? Instead of, let me just ship, okay, this is it. I know Kotlin, let me just ship. This is my focus. Try and figure out, okay, who am I shipping to? How will they actually use this application in this and this way? For example, there's this feature we added in an app. It is so simple for us developers, like swipe to delete. Like you can just swipe and delete an item, and to us it is very simple and basic. Like that's it. But then again, we went to the users, and nowadays the navigation gestures are no longer there. So all you have, your way of navigating is swiping through the screen from certain angles or certain design. So sometimes they would swipe back and delete items they didn't want to delete. And this is
Oh,
a pain for the actual users. It is easier, yes, for us. We thought, this is awesome. But now for the actual users, how usable was it for them? So we had to roll it back and be like, okay, so this is not it. Let's go back and try and adjust that feature into something better for them to actually use. See?
awesome. That's a great insight, actually. Thank you for everyone who joined us today and for also sparing your time to also listen and also gain insight into how you want to improve or tap into the UI world in relation to Kotlin. Thank you for everyone for joining us, and that's a wrap.
Thank you, guys. Thank you for having me.
It's a good one.
Thank you.
Great
Bye.
session, guys. Bye, everyone. Thanks to everyone who joined us tonight. It's been an awesome talk. Thanks again, Brian.
Thank you.